So in part 2 of the basics of sets, we're going to look at first the difference between or statements and statements. This is going to come into play a couple of times during this course. That might be an understatement, but let me give you an example. At the grocery store, Anna picked up chocolate cake mix and vanilla cake mix. That statement is only true if I did both of those things. I picked up chocolate cake mix and vanilla cake mix. Okay? So the and statements, in order to be true, both parts must occur. Both parts must be true. If I were to say Anna needs to go to the store and pick up chocolate cake or vanilla cake, if I come home with vanilla cake, I've met the requirements for an or statement. If I came home and I had a chocolate cake, I would come home and have met the requirements of an or statement. So, for an and statement to be true, both parts must happen, both parts must be true. For an or statement, it's true if either part is true. Okay, so I gave you kind of like a sentence example of an and statement versus an or statement. Before we move on, we're going to take a look at a couple of symbols that are going to make our lives easier. Symbols make our lives easier because they give us a shorthand way to represent words, and so we save time from writing out the full sentence. So here are a couple of symbols we're going to see. First one is this. This one is an element of. Okay. This symbol here, the same thing with a cross through it, is not an element of. The next symbol that I'm going to show you represents the natural numbers, and I write it like this. Okay. But the proper way, like the way you'll see it on the notes and whatnot, it looks like this. Okay, this is my kind of shorthand for shorthand. So this represents the natural numbers. Okay, and then we might see the integers, which is a Z. Okay, and then we also have the reals. Those are different number systems that we might use that we might need to know the shorthand symbol for. Again, I write the natural numbers this way because I find this easier than doing the double slanted thing, but your prerogative. As long as you know what you're writing and you know what you're putting down, if you want, you can write it out as the natural numbers every single time in words, but you're going to see me start writing it in shorthand. So in this example, when we're describing the set, it tells us we're looking for the natural numbers that are greater than 5 and less than or equal to 8. So the numbers that will be in this set are only the numbers that satisfy both of these statements. So I need the numbers that are greater than 5 and that are also less than or equal to 8. So that's going to be 6, 7, and 8. Okay, and that's because it's an and statement. In order for it to be counted, the number must satisfy both parts of the conditions. In set builder notation, we would say that this is the set of x's such that x is in the natural numbers and 5 is less than x, because x needs to be greater than 5, and x is less than or equal to 8. Look at that shorthand. That's so much shorter than writing out all the words that say that same statement. Okay, this next set, we have the natural numbers that are greater than 8 or less than 6. So we include any numbers that satisfy either part of these conditions. So let's think of the natural numbers that are greater than 8. That's 8, 9, 10, 11, 12. Etc., so on forever, and the ones that are less than 6 are 1, 2, 3, 4, 5. Okay, greater than 8 is 9 and higher. I hope I didn't count 8. We'll write it down, and then less than 6. So In roster form, we have the numbers 1, 2, 3, 4, 5. We do not include 6. And then we skip to 9, 10, and then so on forever. Okay? You could have also written it 1, 2, ... 5, comma 9, comma 10, comma ... But this way you get the representation that there are numbers that are skipped. We skip 6, 7, and 8. So in set builder notation, we would say this is a set of x's such that x is in the natural number system and x is greater than 8 or x is less than 6. Okay. Next, we're going to look at the empty set. The empty set is a set with no elements. It is empty, there are no elements, and there are 2 ways and kind of 3 ways to represent this. The first one is a set of brackets with nothing inside. Okay, so this is the empty set, one way to represent it. Another way is a symbol that represents the empty set. So this symbol represents the empty set. And oftentimes it is also called the null set. So this must be very, very important because it has many names and ways to represent it. Okay? So the empty set is important. So we're going to look at a couple examples and determine if it's the empty set or not. So that means, does it have any elements in it? If it does, then it's not the empty set. If it does not have any elements, then it is the empty set. So here in set builder notation, we have x's such that x is in the natural number and x is greater than 6 or x is less than 2. So if I were to write these out, I can conclude that this would be 7, 8, 9, ... and this would be 1. So if I were to write this in roster form, I'd have 1, and then 7, 8, 9, ... So this is not empty. Okay, let's look at the next one. In set builder notation, we have x's such that x is in the natural number, and x is less than 6, and x is less than 2. Are there any natural numbers, counting numbers, that are less than 6, which let me list those out, 1, 2, 3, 4, and 5, and numbers that are less than 2, counting numbers, natural numbers that are less than 2? There is. That contains the number 1. So this one is not empty. Okay, now we have x's such that x is in the natural numbers and x is greater than 6 and x is less than 2. So are there any numbers that could be greater than 6 and less than 2? Well, if a number is greater than 6, then it's also greater than 2. So it's not possible to have this happen. This represents a set without any elements because no elements can make those conditions work. Okay, empty or not. This one's tricky. Okay, this set contains 0. So it has an element. So this one is not empty. It contains 0. This one is the empty set. And then this one is another tricky one. This is the set that contains the empty set. It is not empty because it contains a set. Whew! That's kind of a mind bender, mind twister, but really think about that. In order for a set to be empty, it cannot contain any elements. This is a set that contains another set. Therefore, it is not empty, even though the set that it contains is the empty set. Think on that for a little bit. Okay, let's move on. All right, true and false. We're going to look at that is in symbol and is not an element of. Is 12 an element of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? Yes, it is. Okay, 12 is an element of this set. It's written in roster form. It follows the same pattern. That's what that ellipsis means. So it's just counting up from 1 to 14. 12 would be in that set. Is 8 in this set? Is 8 an element of the set? 1, 3, 5, 7. Well, these are all odds. It follows the same pattern. So it would go from 7 to 9. Okay? So since 8 is even, it is not. I guess we could say false. This is false. And this one up here we can say is true. Okay. Is negative 8 in the natural numbers? No, that is false because natural numbers are counting numbers. There are no negative counting numbers. Okay? A negative number is part of the integers. So I could say negative 8 is in the integers, and that would be true. Okay? 2.5 is not in the natural numbers. That is true because it is a fraction or a decimal. Therefore, it is a real number and it is a rational number, but it is not a natural counting number because counting numbers are whole. Okay, no decimal places. This concludes part 2 of our basics of sets. We're going to have one more section that will hopefully be quite short. So please make sure that you're filling in your guided notes and email me questions, but make sure you watch the next video on part 3.